We're going to talk about multiple representation. So we're still on algebraic relationships. So before that, let's do our do now, talk about equations. A Writer magazine subscription costs $12 per week. Write the equation that describes the total change C for the number of weeks W. Make a table for the input slash output values. So in 0 weeks, he'll make $0. He won't make any money. So again, it costs $12 per week. In the first week, he'll make $12. In the second week, he makes another $12, be $24. In the third week, he makes another $12, be $36. So what is the relationship between W, the weeks, and the cost? The relationship, from what I can tell, is are we adding or building up by multiplying? I think we're multiplying. We're building up by 12, by 12, by 12, by 12. So we're multiplying by 12. What are you multiplying 12 by? You're multiplying the W, the weeks, by 12, and you know the cost. Could we flip this around? Cost is equal to week times 12. Could we rewrite that? You can also rewrite it as cost is equal to 12 groups of the week. $12 for each week. So all three of these equations work. Now it's time to graph it. In 0 week, he makes $0. In 1 week, he makes $12. In 2 weeks, he makes $24. In 3 weeks, he makes $36. So as you can tell, it is if you connect it, it'll be a straight line. So that's our thing. So let's get to what we're going to do today. So in a multiple representation we're going to keep on continue our lesson on graphs with tables and with equations. So Mr. Joseph stops at a donut shop every morning to buy a donut and a cup of coffee. He spends 75 cents for a donut and $2.75 for the coffee. Represent the total amount Mr. Joseph spends for different number of days. Write a short verbal description of the mathematics in a word problem. So from this, what can you tell me? How much money does he spend per day? So if he spends 75 cents and $2.75, it seems as though he spends. So Mr. Joseph spends $3.50 per day. This is what I can get from this. If I have to get some math, this is how much he spends every day. So use the table below to calculate the dependent from the corresponding independent. Again, x-axis is independent. If you have a graph, independent is here, dependent is here. So independent is the x-axis, the y-axis is dependent. Again, this depends on this. So this must be about days, and this must be about cost. The cost, how much he spent, depends on how many days are. The more days there are, the more cost will be. The more he spends, it's because more days have passed by. So in 1 day, he spends $3.50. In 2 days, he spends $3.50 plus $3.50 is $7. In 3 days, $3.50, he spends $10.50. Is there a faster way of doing this instead of adding over and over? In 4 days, he spends $3.50 every day. It'll be $14. So what is the relationship here? Oh, in 5 days, he'll spend $17.50. What's the relationship here? In 1 day, he spends $3.50. It seems like we're multiplying by $3.50. In 2 days, he spends $7. So we multiply it by $3.50. You could keep on doing repeated addition, but once you get tired of adding, it's easier just to multiply. In 3 days, he spent $3.50 per day, so you multiply, you get $10.50. And you multiply $3.50. So the relationship is you multiply the number of days by $3.50 to get the cost. He spends again $3.50 per day. Next one. How much money does Mr. Joseph spend at the donut shop in 1 week? Let's go back. How many days are in a week? 7 days. So there's 7 days, and he spends $3.50 each day. You can continue with this pattern if you want to, or if you want to just multiply by $3.50. That's cool with me. But you know what? I'm gonna continue with this table because I just want to continue with table. So he spends another $3.50. So he spent $21 in 6 days. He spends another $3.50, 7 days times $3.50. He will spend $24.50 in 7 days. So again, he spends $3.50 per day. So you multiply by $3.50. That's a relationship between the number of days and the cost. So let's go. Oh, I cannot remember. $24.50 in 7 days. Define your variable. Write the equation to show the relationship between x and y. So, what do you think these x's are about? These are the number of days. What's the y? It's the cost. So this is the days, this is cost. So what is the relationship? Can you set up an equation? Let's see. So you're multiplying the number of days by $3.50 and you get the cost. So it could be x times $3.50 equal the cost of y. Flip it around. It could be y equal x times $3.50 or y is equal to $3.50x. So say you have $3.50 groups of x. This is the most preferred way. This is the way you'll see it. Mostly written by anybody in any school. All these are good, but I prefer this way myself. Does this equation show an additive or a multiplicative? To do this table, are you adding or are you multiplying? It seems like we're multiplying, we're building up. So it's a multiplicative relationship. Next page. Question. Now it's time to graph it. Using the coordinate plane to graph the data from the table, be sure to label the x and y. So again, the independent is x, that's the days, and the dependent is the cost. So again, this is the independent, and this is the dependent. You've got to know this for your final and everything. Independent, dependent. So, in 0 days, he spends 0 amount. So going back to your table. In 1 day, he spends $3.50. In 2 days, he spends $7. I just memorized these. In 3 days, he spends $10.50. In 4 days, he spends $14. In 5 days, he spends $17.50. And then in 6 days, he spends $21. Hey, it looks like a line. If you connect it, it'll make a line. Describe the graph. What's happening to this graph? The cost goes. The cost goes up with the number of days. So when the days increases, the cost goes up. Cost goes up as the days increases. The cost goes up with the number of days increasing. So that's what I got from this. Identify the independent and dependent quantity. So what are the independent? It's the days. And the days I got were 0, 1, 2, 3, 4, 5, and 6. What are the dependent? That's the cost. What sort of cost did I get out of this? I got all the numbers here. I got 0, I got $3.50, I got $7, I got $10.50, I got $14, $17.50, and $21. Should the points on the graph be connected? Explain your reasoning. I would not connect it. No. It's because does he go there half in the middle of the day? Half of the day? No, he goes there every day, every full day. He shows up one time every day. And he spends that amount of money. He doesn't go halfway between it because once a day. You can't go 1.5 times into either you go into the shop or you go out. Either you're in or out. You can't go like half of it inside and half of your body inside. It's not half of you wanting to eat the food. It's either you totally want to go inside buy it or you don't, not going to do it. So I said no. Next one. Rosa Burns, so let's make calories. You can reverse it and do calories equal to number of hours times 250. Or you could say the number of calories is 250 per the hour. So all three of these equations make sense. So if you know the hours, you multiply by 250, you get the number of calories. That's what we did here. Or you could say, find the calories, you multiply 250 times the hour. Next one. So use the coordinate plane to graph the data. So they already graphed it. This is the x-axis. This is the independent. This is the y-axis. This is dependent. Because the calorie burns depends on the number of hours. That's why hours are independent. Time is usually independent, by the way. And then the calorie burns is dependent. So describe the graph. Well, we haven't plotted. Let's graph it first. In 0 hours, she burns 0 calories. In 1 hour, she burns 500 calories. In 2 hours, she burns stop. I think it's 250. In 1 hour, she burns 250. In 2 hours, she burns 500. In 3 hours, she burns 750. In 4 hours, she burns 1,000. So what's happening to this graph? It seems as though as the number of hours increases, the calories increase. Calories burned increase. So, as the calories go up, the number of hours go up. As the number of hours go up, the calories go up. So identify the independent and dependent quantities. So the independent, again, is hours, and the calories are dependent. So what kind of hours do we use here? We use 0, 1, 2, 3, 4. What kind of dependent we use? We use 0, we use 250, 500, 750, and 1,000. So should the points on this graph be connected? It actually should be connected. But you say why? Is she just exercising for 1 hour, like in that 60 minutes? That's when she's an hour, and she burned at 250 all in that 60 minute? Or is she slowly doing it? Is she like exercising like on a treadmill? Is she running? Like every minute she's running. So every time she runs, she's sweating more and more. And so it's increasing how many calories you burn. So that's why we have to connect it. Because it's showing that as every minute she's exercising, she's burning more and more calories. Alright, next one. Agatha works at a local grocery store after school and on weekend. She earns $7.25 per hour, and she is allowed to work up to 20 hours per week. 3 different representations of the amount of money Agatha are shown below. So in this graph, we show 0. She makes $0. In 1 hour, look like she makes $7.25. In 2 hours, look like she makes $14.50, and so on. So it's slowly going up. In this table, in 0 hours, she makes 0 amount. In 4 hours, she makes $29. So what is the relationship between here to here? Look like we are multiplying by 725, multiplying by 725, multiplying by 725, multiplying by 725, multiplying by 725. What's another way to write this equation? X times 725 equal y. Flip it, y is equal to x times 725, or y is equal to 725 per hour. And so are all these related? Yes, they are. Because it's showing that every hour she makes $7.25. In 4 hours she makes $29. So let's go back to our graph. Does that show that? In 4 hours she makes $29. It does. In 8 hours times $7.25 she makes $58. In 8 hours she makes $58. So it shows it. Yes, they are all related. And that's it. So in this one, what we talked about is how tables, graphs, and equations can all relate to each other. By knowing a table, you can build a graph and equation. By getting an equation, you can build a graph or table. By having a graph, you can build an equation or table. They all are interrelated to each other. They all show the same information. Multiple representations.